Hi friends. Welcome to the YouTube channel DM Info Videos. We are here today with an interesting new video to enlighten the viewers. Continue watching this video till the end so that anybody will come to know about the much unfamiliar information, and wait eagerly for the episodes to publish regularly. Please like and comment, share, subscribe and tap the bell icon for receiving the notifications on the upcoming videos. Trust that everyone must have watched the previous videos that were published. If not, please click the links given below to know them and share. Episode 15. In this episode, we will learn about steel structures used for civil engineering construction. It will speak in this video with an introduction, what and why required, history and development, advantages used in the construction of residential and infrastructure projects, steps and procedures, and extract under this topic. Introduction. If you are looking for the most cost-effective building type, it is essential to consider your potential long-term savings along with your initial investment in any shape of the structure. Let's think about steel structure. What is a steel structure? The steel structure is a metal structure made of structural steel, which is a construction material fabricated with a specific shape and chemical composition to suit a project's requirement. Its components connect to carry loads and provide complete rigidity. Common shapes include the I-beam, HSS, channels, angles and plate. Because of the high-strength grade of steel, this structure is reliable and requires less raw materials than other types of designs like concrete structures and timber structures. In modern construction, steel structures are used for almost every type of structure, including heavy industrial buildings, high-rise buildings, equipment support systems, infrastructure, bridges, towers, airport terminals, heavy industrial plants, pipe racks, etc. Why steel is a better building material? Wood has been the preferred material for the construction of homes and most other types of structures for many years. The wide availability, self-replenishing nature and ease of use are the reasons for this. The modern manufacturing infrastructure and the reduction of unprotected sources of wood are creating a new trend in domestic and commercial construction. Steel is well known for providing structure and strength unlike any other when it comes to construction. The durability and potency that steel provides are not matched by the likes of wood or concrete. Steel is becoming the building material of choice for many large constructions. It is more durable than wood when appropriately treated. It is not heavier than the preferred wood types, such as oak, and it does not require the depletion of our forests to use for building. In 2002, the U.S. Department of Housing began a study wherein they built one steel frame home alongside a home built with traditional wood materials. In the short term, the steel building cost 14% more to build than the wood home. However, over the next few years, the cost to own and maintain the steel-based structure was significantly lower. Since then, manufacturing processes have advanced enough to narrow the construction cost gap of steel to wood, making steel clear superior to wood at every point in the life of a home. Naturally, steel is more resistant to natural disasters, such as fires, hurricanes, floods, and earthquakes. Steel is impervious to the ravages of mold and the dreaded termite threat, which causes millions of money of damage to real estate every year. Steel construction poses little to no threat to the environment as our trees and forests need not be cut down to support it. For all these reasons, steel is rapidly becoming the building material of better choice for many developing organizations. History. The use of steel for structural purposes was initially slow. The Bessemer process in 1855 made the production of steel more efficiently. Cheap steel, which had a high tensile and compressive strength, and good ductility, was available from about 1870, but wrought and cast iron continued to satisfy most of the demand for iron-based building products, due mainly to problems of producing steel from alkaline ores. These problems, caused principally by the presence of phosphorus, were solved by Sidney Gilchrist Thomas in 1879. It was not until 1880 that an era of construction based on reliable mild steel began. By that date, quality steel was produced and had become reasonably consistent. In the United States, The first steel-framed building was the Rand McNally Building in Chicago, erected in 1890. The Royal Insurance Building in Liverpool, designed by James Francis Doyle in 1895, erected 1896 to 1903, was the first to use a steel frame in the United Kingdom. Development: earlier mentioned hot-rolled steel sections are heavy and difficult to transport. The cold-formed steel sections started to mix up with the execution in the 20th century as they are light in weight and easy to transport. Cold-formed steel. Steel mills produce galvanized sheet steel, the base material for the manufacture of cold-formed steel profiles. Sheet steel is then roll-formed into the final profiles used for framing. The sheets are zinc-coated, galvanized, to prevent oxidation and corrosion. Thin sheets of galvanized steel cold-formed into steel studs as a structural or non-structural building material for construction projects. The profiles used in residential construction are the C-shaped stud, the U-shaped track, and varieties of other shapes. The framing members produced in a 12 to 25 gauge thickness. Advantages: strength, beauty, design freedom. The combination of strength, durability, beauty, precision and malleability of the steel gives architects broader parameters to explore ideas and develop new solutions. Steel has a natural beauty that most architects can't wait to take advantage of. Steel allows for long column-free spans, and you can have a lot of natural light if you want it in any shape of structures. The outcome is more predictable and repeatable, eliminating the risk of on-site variability. Fast, efficient, resourceful. Steel structures are fabricated at the factory and rapidly erected at the construction site by skilled personnel that makes a safe construction process. A whole frame is erected in days rather than weeks, with a corresponding 20% to 40% reduction in construction time. In single dwellings, steel allows fewer points of contact with the earth and reduces the amount of excavation required. It is less in weight when compared to other materials such as concrete and enables a smaller, simple foundation. The steel structure is the cost leader for most projects in materials and design. It is inexpensive to manufacture, and erection requires less maintenance than other traditional building methods. The efficiencies in execution translate to considerably accelerated project schedules, reduced site management costs and an earlier return on investment. Adaptable, accessible. Non-composite steel beams can be made composite with the existing floor slab and cover plates added to the beams for increased strength, beams and girders reinforced quickly and supplemented with additional framing or even relocated to support changed loads. Steel framing and floor systems also allow easy access and alterations to existing electrical wiring, computer networking cables and communication systems. More open space. Steel sections provide an elegant, cost-effective method of spanning long distances. Extended steel spans can create large, open-plan, column-free internal spaces, with many clients now demanding column grid spacing over 15 meters. In single-story buildings, rolled beams provide clear spans of over 50 meters. Trussed or lattice construction can extend this to 150 meters. The minimal number of columns makes it easier to subdivide and more spaces. Steel-built buildings are often more adaptable, with great potential for alterations to be made over time, extending the lifetime. Endless recycling. When a steel-framed building is demolished, its components can be reused or recycled. Steel can be recycled endlessly without loss of properties. Nothing wasted. Steel saves natural raw resources since around 30% is already being made from recycled. Fire resistance. Advanced design and analysis techniques allow precise specification of fire protection requirements of steel-framed buildings, often resulting in significant reductions in the amount of fire protection required. Durability, earthquake resistance. It can withstand extreme forces or harsh weather conditions, such as strong winds, earthquakes, hurricanes and heavy snow. It is unreceptive to rust, not like wood frame affected by termites, bugs, mildew, mold and fungi. Steel is the material of choice for design because it is inherently flexible and ductile. It flexes under extreme loads rather than crushing or crumbling. Aesthetics meet function. Steel's slender framing creates buildings with a sense of openness. Aesthetic qualities complemented by functional characteristics include its exceptional spanning ability, dimensional stability over time, acoustic noise dampening ability, endless recyclability and speed and precision manufactured and assembled with minimal on-site labor. More usable space, less material consumption. Steel's ability to maximize space and internal width with the thinnest shell possible means lighter and smaller structural elements are achievable. Walls can be thin because the strength and excellent span capability of steel mean there's no need to build solid, space-consuming brick walls. Lighter material, lesser impact on the environment. Steel structures can be significantly lighter than concrete equivalents and require less extensive foundations, reducing the environmental impact of the build. Steel pile foundations, if needed, can be extracted and recycled or reused at the end of a building's life, leaving no waste material on site. Use in buildings and infrastructure projects. The possibilities for using steel in buildings and infrastructure are limitless. The most common applications are listed below. Buildings. Reinforcing bars. These provide tensile strength and stiffness to concrete used in buildings. Steel is used because it binds well to concrete, has a similar thermal expansion coefficient and is relatively robust and cost-effective. Reinforced concrete is also used to provide deep foundations and basements and is currently the world's primary building material. Structural sections. These provide a strong, stiff frame for the building and up to 25% of the steel used in buildings. Sheet products are used for roofing, purlins, internal walls, ceilings, cladding, and insulating panels for exterior walls. Non-structural works. Many non-structural applications in buildings, such as heating and cooling equipment and interior ducting. Internal fixtures and fittings such as handrails, shelving and stairs made. Infrastructure. Transport networks, for bridges, tunnels, rail tracks and in constructing buildings such as fuel stations, railway stations, sea and airports. Utilities like fuel, water, and power. Used for these applications in underground pipelines distribute water to housing from the source and distributing gas. The rest is a rebar for power stations and pumping houses. Steps for constructing steel structures. Comprehensive building directions are crucial to safely and successfully erect a steel building. 1. Do the foundation and place the anchor bolts. 2. Erect columns to anchor bolts in concrete. 3. Fix horizontal beams to all columns and overhead door jambs. 4. Assemble the trusses on the ground. 5. Hoist completed trusses onto columns and connect. 6. Fix rafters and purlins on the top of the trusses. 7. Double-check that all primary and secondary framing is erected, plumbed and the bolts tightened before sheeting begins. 8. Install the wall panel and wall insulation, if required. 9. Attach roof insulation, if applicable and cover the roof panels. 10. Add any translucent panels, gutters, downspouts, or other trim and seal the building to finish it off. Procedures for the construction. Construction of steel frame structure foundation. Steel column construction. Erection of steel beams. Floor systems are used in the steel frame structure construction. The procedures are explained further. Construction of steel frame structure foundation. Steel frame structure construction begins with the construction of its foundation. In one of the previous videos, we learned that the type of foundation required for the given structure is based on the soil-bearing capacity. Soil investigation for surface and subsurface exploration is used to assess the condition of soil on which steel frame structure rests. For example, when moderate or low loads are imposed, then it is advised to use reinforced concrete bearing pads or strip foundation. These foundation types transfer loads to soil and are capable of supporting loads. In case of poor soil strength and large imposed load, it is recommended to consider pile foundation. The pile foundation would transfer the burden of the structure to the stiff soil. Steel column construction. The next step of steel frame construction is the placement of steel columns. The section of the steel is specified based on the load imposed. There are various steel column sections to choose from, and these steel columns are produced in advance. The most significant point in column installation is the connection between foundation and column and splices between columns. Regarding foundation to column joints, base plates are welded to the end of columns. The most desired shape of the base plate is a square and rectangular shape. It should be known that the most desired shape of the base plate is rectangular and square shape because such plates provide the most significant spacing between the bolts, which is desirable. As far as column splices are concerned, it is provided in every 2 or 3 stories to ease the erection process and simplify steel column production and deliveries. The distance between floor and column splice is about 60 centimeters. When circular steel columns are used, a weld connection is used to join both steel columns above and below. Erection of steel beams. Various prefabricated beam sections are available to be used in the construction of multi-story steel frame structures. Beams commonly transfer loads from floors and roofs to the columns. Steel beam members can span up to 18 meters, but the most usual range of steel beam spans range from 3 meters to 9 meters. While steel beams were erected, column-to-beam connections and beam-to-beam connections were encountered. There are different types of the column-to-beam connections, which are selected based on the loads imposed on the column-to-beam joint. For example, if the joint is subjected to vertical loads only, then simple connections are used. If the joint is subjected to both vertical loads, shear force, and torsion forces, then the entire depth end plate connections and extended end plate connections should be considered. As far as a beam-to-beam connection is concerned, the end plate beam-to-beam connection is used to join secondary steel beams to primary steel beams. Since the top flange of secondary beams supports the floor system, it must level with the top flange of the primary beam. It can be done by notching the top flange of the secondary beams. Alternatively, the projected bracket is welded to the primary beam, and then the secondary beam is attached without the need for notching secondary steel beams. Floor systems used in steel frame structure construction. There are various types of floor systems used in steel frame structure construction. Floors can be made as the beams are erected. Floor systems support vertically applied loads, and also they act like diaphragms and resist lateral loads through the use of bracings. Examples of floor systems include short-span composite beams and slabs with metal decking, slim-dick, cellular composite beams with slabs and steel decking, slim floor beams with precast concrete units, long-span composite beams and slabs with metal decking, composite beams with precast concrete units and non-composite beams with precast concrete units. Construction of bracing and cladding in steel frame structures. Bracings resist lateral forces imposed on the structure and transfer lateral loads to the columns and then to the foundation. Regarding cladding of steel frame structures, various types of cladding such as brick and sheet used to protect the inside area. Extract. The world population is expected to increase by 2 billion persons in the next 30 years, from 7.7 billion currently to 9.7 billion in 2050, according to a new United Nations report launched in 2019. It will accompany rapid urbanization. As the need for buildings and infrastructure continues to grow worldwide, reducing the consumption of natural resources and associated emissions is crucial for future sustainability. Construction is one of the most steel-using industries, accounting for more than 50% of world steel demand. Buildings from houses to car parks to schools and skyscrapers rely on steel for their strength. Steel is also used on roofs and as cladding for exterior walls. Steel is not only affordable, readily available and safer, its intrinsic properties, such as strength, versatility, durability and 100% recyclability, but also allow for improved environmental performance across the entire life cycle of buildings. The advanced high-strength steels used in steel plate applications also find uses in several related industries. Offshore oil rigs, bridges, civil engineering and construction machines, rail carriages, tanks and pressure vessels, nuclear, thermal and hydroelectric plants, All these applications benefit from the attributes of modern steels. Whilst the operation of buildings accounts for 28% of global CO2 emissions, many opportunities for reducing emissions and mitigating climate change. Steelmakers around the world are increasingly providing construction solutions that enable energy-efficient and low-carbon neutral buildings. For example, in the HAMK Sheet Metal Center in Finland, a near-zero energy building, NZEB, steel solutions brought down the cost of electricity. Thank you viewers for sparing your valuable time and watching steel structures on this YouTube channel DM Info videos. It must have enhanced the understanding of steel structures, placed everyone in a new light of exposure, and inspired us to learn more. Else, online technology helps us repeatedly viewing to get the benefit. Kindly wait for the upcoming video to publish early. Keep watching the videos regularly that are published on this channel. Would you please share and subscribe for more fabulous inspiration? Thanks again and wishes to prosper ever.